Directly, so today's session is all about the statistics and visualization techniques, like visualization techniques, histograms, and pie charts, a scatter plot, and a different type of heat maps. That type of analyzing graphs we will see. So, as we discussed, in statistical method, majorly the basic concepts are mean, median, mode, and mid-range of the data. Then we analyze the data dispersion. By analyzing the data dispersion, we can take the valid and quality-oriented decisions. So the basic statistical methods are mean, median, mode, mid-range, standard deviation, variation, quantile. All these parameters we will use to analyze the data. By with that is median position. Median will divide the data into two parts, lower part and a higher part. And median and mode. Mode is nothing but it represents the frequency based one. How frequently a data is repeating. The most frequently happening data item is considered as a mode of the data. So the relation between the mean, median, mode is here mean minus mode is equal to into the difference of mean and median. So these three basic things are used to basically, fundamentally to analyze the data properties. And likewise, and we will use some other statistical methods like standard deviation and the normal distribution also. What is the normal distribution? When we plot the data in two-dimensional or multi-dimensional data, then the mean, median, mode, these 3 points are coincide, then we will say the data is normal distribution and the data is looking like a bell-shaped curve as we are seeing in the middle diagram. The 3 mean, median, mode, all these 3 points are coincide here. Left one is negatively skewed. Negatively skewed means the density of the data is moving right side of the median. Then the mode value is slightly deviated from the median. And conversely here, positive skewed. Here, the data distribution is more less than the median position. Then mode is deviated from the median value. And here, and as we discussed, variation and standard deviation. Okay, so variation is how the data points are getting deviated from the mean value. So here we are taking the sum of the all deviations and average of that. We are considering that as a variance, and square root of variance we are considering it as a standard deviation. So variance and standard deviation is also one of the statistic techniques to measure and observe the data points. And here some of the advanced statistical methods like quartiles, interquartile range, 5-number summary, box plots, variations here. And we can observe here, we will discuss, yeah. See here the data distribution is divided into 4 quartiles. So first 25% and second 25%, third 25% and last 25%. Here the second quartile is referred as the median. This median divides the entire band into 2 halves, like in a normal distribution, and the distance between the third quartile and first quartile we will refer it as a IQR. It is interquartile range. Why we are doing this quartile division means here by doing this we can identify the outliers of the data. And here this is a box plot, especially in the box plot we will see here. So in the box plot, 5 matrix we will take. So this is the lower extreme and lower quartile, median, or second quartile, upper quartile, and upper extreme. So the data points, those falls Beyond this range will be considered as a outlier, and we will not consider the outlier for the analysis purpose. But even then, outliers are having some significant role in analysis purpose, especially in credit card fraud detection, cyber crimes. The outliers are also giving you the important information. And okay, we will move to the R Studio environment. I will explain you some of the options, some of the statistical programming methods, how we can, what are the different libraries we are using in running the statistical methods. Let us move to the IDE, R Studio IDE.
Sir, Nageswar sir, voice is not clear, sir.
So here, this is a R Studio. Uh, so this is a IDE here. I am taking the two series of data items. So A and B. A and B are two vectors. So here I am running here vector A and vector B and printing the length of 2, 1. So vector A and vector B, both of them are having the 20 data elements. As we discussed, mean, our programming language is very rich in terms of libraries. We are using the here mean value to find out the mean average value of A vector series here. So this library will give you the will find out the sum of the elements divided by total number of elements, that is 20. So we are getting the here uh, elements mean value is 4.985 for this series of mean value. Second one is median. Median is when the data is sorted in the ascending order or descending order, the middle position element represents the median value. So here it is 5.05 is the median value, and mode. Mode is frequently happening or occurring element in the data series. There is no direct library function to call the median, so we have written here some set of instructions to run that one. So here what we are doing, first we are finding the distinct elements and finding the frequency of or occurrence of each and every distinct element and finding the maximum occurrence value here. So when we run this one, we got the value 7. Since in the series 1, the element 7 is repeated more number of times, so that is considered as a mode of the first series of elements. And the next one is standard deviation. So standard deviation of the series A is, so that is 2.7 standard deviation, and variation that is 7.71. So standard deviation is the square root of simply variation. These two metrics, standard deviation and variation, will be used to measure the how the data distribution is looking like. The data distribution, if the variation is very high, then the data is deviated much from the mean value. And next one is correlation. Correlation is measured in between the two variables, whereas standard deviation and mean, median, mode, all these metrics will be measured only on a single series of data items, whereas in covariance, correlation is measured in between the two variables or two data series. Here, the correlation of A and B series is minus 0.11. Correlation takes the values in between the minus 1 to plus 1. So minus 1 represents the negative correlated, plus 1 represents the positive correlated. 0 means there is no correlation. Likewise, another variable, another statistical method is covariance. Here, covariance of these two minus 0.8. The value of the range of the value for the correlation is minus 1 to plus 1, whereas the covariance will take any one value, negative to positive values. And next one is normal distribution or scaling, normalization. Why we need to do the normalization means I want to bring down the high range of the attribute values or feature values to the one particular range of values, like minus 1 to plus 1. Then I will go for the normalization. Usually normalization will be done to train the model very quickly. If the model is trained with the high range values, then model will get trained very slowly or poorly. Instead of that, by scale down the range of the values, the model will get trained very quickly, and it can give you the quality inferences. So here, the data series A is normalized here. After normalizing, the data series is looking like this. See here, we could see the values minus 1 to plus 1. So these are all the basic statistical methods that we can run in the R programming language. Likewise, regression. Regression is also one of the statistical method. Of course, it is a classification method, one of the classification method where we, in regression we can predict the continuous values rather than categorical values. But still, we can use regression is a very good tool to predict the missing values in the data set. If any data set in the data set any feature is having the some of the missing values, to fill the missing values we will prefer the regression. With the help of regression we can fill that not available data items. In regression what we will do, first we will plot the data items into the two-dimensional space, and we will do the line fitting here. Once we found a line that is covering all the data points with minimal deviations, then we can give the unique query points along the one axis, and we can take the predicted values on the other axis. Okay, here I am taking the one example of the cars data set here, cars data set. So we will see the car data set. Car data set is having two variables here, speed and distance. Speed reference, okay, so this reference, when a vehicle is moving at one particular speed, then you apply a brake, then how much distance it will take to get stopped. That is the information is coded in the data set called cars. So I'm taking here, so I'm plotting that data set values in a two-dimensional, and I'm printing the cars data set here. You can see here, here we are having 50 instances. The first attribute represents the speed, second one is distance. And using the plot function to plot the data in two-dimensional, and LM is the function. So our function called LM that is used to build a linear model. So here, see in the graph we can see here, so the data is plot in the x-axis I taken the speed, on y-axis I taken the distance. So I plot the data here. Next one is line fitting. For that I am using the function called AB line. see here, with the help of AB line, the line is added here. The line is added here. So it is the line fitting is this line is representing all the data points here. Once the line is represented, I will take the query points on the x-axis and I will take the prediction on the y-axis. For example, the vehicle is moving at somewhat 22 miles per hour here. I will intersect this from here to this line here, somewhere here, and parallelly I will draw a line onto the y-axis. It will intersect nearly 65 feet. So that means whenever a vehicle is moving at 22 miles per hour, then we apply a brake, then it will take nearly 65 feet of distance to get stopped completely. So this is the linear regression. And once the line is fit, here I am taking the some vector of 50 data points and sending that to the for the prediction purpose. Here function called predict will take the predictions from this model. So here we could see the list of the values here. So this represents the relation between the speed and distances. So this is the linear regression. The R programming language supports the regression with the help of LM model, linear model, and AB line function. LM model will find out the coefficients of a straight line like the slope and y-axis intercept, and AB line will add the line to the data points. Once the line is added, then we can post any query points and we will take back the prediction values. And another statistical methods is the data frame. Okay, data frame is for manually building the data set. We will use the data sets either in the form of CVS comma separated values or Excel sheet and any other form. But if you want to design a data set manually, then in our programming, we will use the data frame function. Here I am taking the three sets, three attributes calling name, score, attempts, and qualify. Here building the student attribute values here. So student name, student score in a examination, how many number of attempts he made, and what is the result, whether he qualified the examination or not, with the help of data frame here. Okay, and I'm running this one data frame function. Then into the data frame. So it will build the data frame internally. 1 second. So here we could see the data frame. So name, score, attempts, and qualify. And to access the data from the data frame, we can use the pull method or some pulling methods from the data frame. So with the help of pulling, we can extract the one particular specified feature or set of features from here. So this is the data frame. And next one is visualization techniques. So here I'm taking the one data set called air quality data set. Air quality data set is having the data like ozone content in the air and temperature and air quality, wind speed. These attributes it is having, and here we will see a different type of visualization techniques. That is, first one is bar plot. In a bar plot, we can see the vertical, the data will be represented in a form of bar graphs. I will run. So we could see the details like this. So histogram is frequency based representation, frequency based graph. So The x-axis, the values will be divided into disjoint sets, and that frequency is represented along the y-axis here. You could see that difference. The intervals are 55 to 60. There are six data items, and 60 to 65 there are 10 data items like that. So this is a histogram. Histogram represents the frequency based. First, the range of the x-axis is divided into disjoint sets, and for each disjoint set, the number of data items are represented. Number of data items or frequency is represented on the y-axis. And next one is box plot or so already we have discussed box plot uh, is a graph basically based on the quartile. So here the value, the data distribution is divided into in between this starting point to this minimum low value and maximum high value. In between the data distribution is divided into four quartiles. Okay, so it is the median value. And here we could see the some bubbles, it is outliers. The values those are out of the range are called as the outliers. Because of these outliers, we will not consider these outliers in the analysis of the any machine learning training model. But still, it is having these outliers are having some significance in the alerting systems like the credit card misuse and any cybercrime related applications. And scatter plot. So scatter plot will be plotted in between two variables or two attributes. Here on x-axis I taken the ozone concentration and y-axis I taken the month-wise observation. Month-wise observation. So here we can analyze the relation in between the two parameters or two features. So we can say here there is a linear relation between the concentration and monthly observation. Pi means the observation in the month May, June, July, August, and September, like this. So in previous one we will analyze only one attribute or one feature. In scatter plot we will see the relation in between the two parameters. And next we will see the heat map. Heat map. So it is a heat map. In a heat map, first we will take the here also this is also map to analyze the relation in between the two parameters. And first we will plot the data into rows and columns in a table format. Here the values those that are having the similar values will be applied a similar color. So we can say the data items those are depicted in this area are having the similar property. Okay, so this is the one way of representation of data, and this is the world is another kind of data visualization technique. But here, I don't think so. This version of the R programming will support this one. Uh, no, it is not available. This CSV world cities dot CSV I am using here. This file is not available. Not showing. So these are all the different type of visualization techniques like bar plot and histogram frequency based representation, and box plot. And box plot is a here it is a quartile. Entire data distribution is divided into quartiles. Based on the quartile and median values, we will analyze and we will identify the outliers, and the scatter plot to identify the difference, the relation in between the two parameters. And likewise, it is a heat map color based map where the data combinations of the input attributes are having the same output combination. Then those will be depicted in a same color, unique color. These are the different type of uh, visualization techniques. Yes, because of internet connectivity deliver much in today's session. Sorry.
Srinivas sir, Nageshwar sir. Hello participants, my voice is clear? Madam, start on madam. Okay. No problem, madam. Okay. Hello? Hello?
Yeah,
Nagesh?
Dilip sir, your voice is audible.
Thank you, madam. Thank you. Thank you. Nageshwar sir, participants, any queries, please post the chat box. సార్ మీ వాయిస్ క్లియర్గా లేదు చూడండి నేను మాట్లాడుతున్నాను ప్రియాంక మేడం ప్రియాంక మేడం
Yes, sir. Good afternoon. Good afternoon, sir.
టుడేస్ నెక్స్ట్
Hello.
రిసోర్సెస్ హలో మేడం యువర్ వాయిస్ ఇస్ క్లియర్
Sir, am I clear, sir?
ఎస్ మేడం యువర్ క్లియర్ మేడం
Yes, sir. Sir, good afternoon, one and all. Myself, Priyanka, Assistant Professor of CSE in Narsimha Reddy Engineering College. Sir. Respected faculty members and research scholars, I welcome you all for this um, FDP program. I would like to introduce Dr. K. Sri Divya Garu is currently serving as an assistant professor in Madanapalli Institute of Technology and Science. Madanapalli is a department of computer science and technology. Her research areas include big data analytics, machine learning, artificial intelligence, IoT, and cloud technologies. She published many papers in peer-reviewed journals. She is an ex-EXCOM member of IEEE and member of ACM, and a member of various prestigious organizations like CSI and ISTE. She received APJ Abdul Kalam Award under the category of Best Teacher for the academic year 2021. Thank you. Welcome you, ma'am.
Thank you, Priyanka.
Thank you, ma'am.
So, good afternoon, one and all. Before going to start the session, my wholeheartedly thank you to Ms. for giving me this opportunity to deliver a content on big data analytics and data analytics. Thank you, Dilip sir.
మేడం థ్యాంక్ యూ మేడం ఫర్ యువర్ వాల్యుబుల్ టైమ్ అండ్ యాక్సెప్టింగ్ అవర్ ఇన్విటేషన్ మేడం థ్యాంక్ యూ మేడం
Pleasure is mine, sir.
yes
Shall I start
yes madam please
sharing
share
my
your
screen,
screen
sir?
yes madam please madam your screen is visible madam thank you
Right. Okay, sir. Right. Right. So today I'm going to talk about data analytics and big data analytics. What is the difference between data analytics and big data analytics? So before going to know about data analytics, let me discuss about what is meant by big data. See, as the term itself says, like it is an extreme large volume of data where human can't able to manage it. right? So it refers like it can able to hold large amount of data, so irrespective of its size. So big data refers to this not one type of data, different types of data. So it doesn't bother about the size, it doesn't bother about the time to store, it doesn't bother about the that type of data, right? So we can able to work with different types of data, and it can enables them to surpass the capabilities of traditional data management tools. So before prior, so if we want to store data means, so 100% surely we will take the help of some secondary storages like hard disk or this floppy drive, cd drive and all. But now we have a new technology where we can able to store enormous amount of data on our system itself based on the capacity of our system. And even we have new technologies like cloud and all, where it can able to store enormous amount of data, and it has a functionality of elasting the uh, large amount of storage also. So the way that data warehousing nowadays and data lakes are all doing this. So cumulatively we call this data warehouse and data lakes, so which we call it as big data, right? So some of the data set that we truly consider as a big data is stock market data. So that is the first and foremost best example of big data is stock market data. So where every day, every single day, so there will be some sort of analysis on stock market. And of course with what we people are very much familiar is social media data. So this every minute second some petabytes, some yottabytes of data are generated. Games, scientific and research data, so everything will be generated on stock market data. So this data technology where it can able to manage huge amount of data. So, coming towards the overview, see, first and foremost, big data is useful for the industries that gather and exploits the data. So that is, so this industries like stock market is not an industry. It will analyze all the data related to industries. And second thing is this social medias like Facebook, Insta. So all these things, all these areas need some sort of analysis for the data, right? So this big data which can able to store large amount of data generating by these type of these type of social sites and all. So when we talk about industries that gathers and exploit data, see, the first one is credit card companies with monitors purchases, how many number of people have taken the credit cards, how frequently they are purchasing with that credit cards, right? So they reach some sort of credit point. So likewise everything should be monitored, everything should be stored. So this big data will manage all this stuff very easily. And we talk about next mobile phone companies analyzing the call patterns or the social networks which gathers the information and which intrinsically views how data usage grows, how frequently users are using this type of social media networks. Everything will be viewed, processed and stored by a new technology called big data. Of course we can't say it as a new technology, it's a very fast forward technology. Right. So, what are all the attributes defining big data characteristics? As everyone knows that big data is nothing but large amount of data. So, which follows different type of characteristics for our big data. So, the first and foremost characteristic is volume. So, big data can able to store large volume of data. So, irrespective of its size, irrespective of its type, irrespective of its irrespective of its type, maybe it can able to store Sir, I'm audible.
Yes, madam, audible now.
See, from how much time I'm not audible for you?
5 to 10 minutes, madam.
Oh my God! So continuously, I'm saying. See, where I
Madam,
stopped.
clear your PPT.
Okay. See, from here I stopped.
Yes, madam. Can you go to the seventh slide?
Seventh. Okay, okay.
Yeah, please, madam, please.
Is it audible now?
Yes,
Is
madam,
it
audible. Please go.
particular format or order? So just like transactional data is nothing but the data generated by some sort of banks. So transactions what we did not only once. So whenever we go for any marts like mart or any supermarkets likewise, so they will give in terms of table, right? So a number of items we purchase, so what is the name of the item, so the number count of item and bill likewise. So all those things which is nothing but a type of tabular data, which we call it as a transactional data. And we have OLAP, that is online analytical spreadsheet, that is comma separated sheet, so where the data will be stored in a particular order. So this is how the structured data will appear like. So data set, simply we call it as a data set. Well, the data is available in terms of rows and columns, which we also call it as an instances in our machine learning term, right? So this is nothing but next a semi structured data. So this semi structured data which says about like, so we need some sort of data. See, that data will be designed with the help of existing type of sources. So this is an XML, so where we use the different type of tags to appear the what are the data that we required actually. So the data what we required will be achieved through the inbuilt some sort of tags or syntaxes, whatever we call. And so this is which we call it as semi structured data. And next we go for quasi structured data. So quasi structured data is also type of a semi structured data, so where it will redirects from one page to another and another page to another, so which we call it as, so there will be some sort of link between one particular place to another particular, so likewise, so which we call it as quasi structured data. And next one, this is unstructured data. So what this unstructured data says about us, so the data won't be in terms of a particular format, or it don't use any particular type of tags, right? So it is a type of image data, so which we call it as an image data. It may be a type of video data, audio data, or a text file or word file. So we can't say like, so this much only file we have, this type only we have. So in word file we will add text data, we can keep some sort of image, so likewise, right? So all those stuff which we call it as unstructured data. And so there are different type of repositories. So repositories is nothing but a storage. So when we talk about this three types of data, right, structured data, unstructured data, quasi-structured data, and semi-structured data, right? So we talk about those four types of data. So now where we need to store this types of data, so the place which we call it as repository, where we can able to store different types of data, right? So when we talk about spreadsheets, and data marts, spreadsheets which stores large volume of uh, database related data for keep tracking of that analytics part, right? So we can provide some sort of analytics with that our with our spreadsheets. And we have data warehouse, where it is completely centralized data container, which helps us to investigate different type of business intelligence, which we call it as BI, right? Business intelligence. So this data warehouse supports business intelligence and reports, but it restricts to some sort of analysis, and it won't give 100% analysis. So completely this analysis depends upon the database and a different type of IT sector related schemas, so that will identify the data warehouse related stuff. And we talk about this analytical sandbox, which we call it as workspaces. So where here we can able to store any type of data, right? Data assets gathered from multiple sources. So for example, when we talk about the LinkedIn, so all the data which relates about different type of domains and technologies, so which enables this flexible and high performance analysis in the environment of different type of databases. So this which helps us to reduce the cost and the risk associated with data replications. So these are different type of data repositories. So as we know, like Kaggle is a data repository, GitHub is a data repository. So we can able to, so data.gov.in is a data repository. So government related data and all is available at data.gov.in. And so when any technical stuff that we need, that is available in GitHub. So any other data sets, that is available in Kaggle. So likewise, we have many data repositories available for processing. So whenever we talk about big data system tools, so whenever the data managing is a little bit tricky, then we use some sort of tools to manage it. Whenever human is not possible to manage such enormous amount of data, so then there comes a technology or a tool which helps us to manage this data. See, among that, the first and foremost, cloud. So cloud can able to provide um, a, a storage area to store such large amount of data. So as the data increases, the elasticity, the one of the best feature is elasticity of cloud. So that elasticity which makes us a cloud to elaborate. So cloud provides providers like AWS, Azure, and GCP. All those things are cloud providers. So where each and every cloud provider have their own data warehousing and data lake implementation to store enormous amount of data. See, among that few tools here, GWS Redshift, this GCP, AWS Redshift, GCP BigQuery, Azure SQL, and Azure Snap Analytics, Azure Data Lake. So these are very, very useful tools to store first and then process next, right? First for storing the data and then for processing the data. Apart from that, so there are specialized software like Snowflakes, Databricks, even open source solutions like Apache, Hadoop, Storm, Open Refine. So these are different type of tools available. Of course, we are all academicians, so we are very much familiar with this Hadoop, right? So Hadoop is nothing but a type of distributed file system, Hadoop distributed file system, where we can able to store enormous amount of data uh, by dividing your data into chunks, and that will be stored at a place called data node, where each and every data node capacity depends upon the data what we store. Actually, if my system capacity is 1 GB, or my hard disk my RAM capacity is 1 GB, then I'll use my system has a node to store that 1 GB data. So I won't insist the system to store 2 GB or data or 3 GB of data, right? So this, which we call it as commodity hardware, where which we use each and every system as a data node based on the capacity of storage. So that is a one more advantage of big data. And whenever we talk about this analytics, so up to now we have talked about this big data, storing structured data, unstructured data, quasi structured data, and semi structured data. So now we need to do some sort of analytics analysis. So what are it? Maybe it may be your structured data. It is very easy for us, for our analytics to do analysis on structured data rather than remaining, because it has a separate format. It has a I mean, which we call it as, it has some sort of template to do analytics. So now coming to what is meant by this analytics. Data analytics is a process of analyzing data in order to extract meaningful data from the given data set, right? So here that data set is nothing but our big data. Am I right or not? Data set is nothing but a big data. So we can able to extract, we can able to gather the data from the big data in a meaningful sense is nothing but data analytics. So these data analytic techniques and methods are carried out on big data in most cases using what? Machine learning algorithms. So obviously the one and only extracting procedure through machine learning itself, right? So the primary goal of this data analytics is to help individual or organizations to make informed decisions based on the patterns, behavior, trends, preferences, and different types of versions. So if I need a type of analysis in terms of bar plots, in terms of pie charts, all right, so in terms of separate analysis, right? So all the stuff that we can easily do with this data analytic part. Surely for this we need to take the help of any one particular programming language to do this. So obviously the handy programming language what we prefer is Python, right? So that we have different type of matplotlib like libraries available. Obviously Python is rich with libraries, so we can able to easily derive that analytics using this Python language. For example, businessmen can use this analytics to identify their customer preferences, purchase analysis, and market trends. See all the stuff that can be do with this type of data analytics. So in scientific sense, a medical research organization can collect data from different medical trials and evaluate the effectiveness of drugs or on patients, and how it will works. Everything will be recorded, everything will be analyzed through this data analytics. So combining all this analytics with the help of data visualization technique will which gives a clear picture of how this data analytics will be happen, and how it is flexible, and how it will be purposefully useful for the users. So there are different types of data analytics. First one, descriptive analytics. There are mainly four types. First one, descriptive analytics, diagnostic analytics, predictive analytics, and prospective analytics. So these four are very, very basic and traditional analytics actually. So right. So first one, descriptive. So which it talks about understanding what has happened in the data set. See how the data set will be, what the first instance talk about, what the second instance talk about, or what the feature talk about. See why, what is the necessity of using that features. See, is there any selection of features will be there, right? So can we remove this feature which is not useful for us to do this analytics. See such sort of analysis which we call it as a descriptive analytics, so which refers to understanding what is happening in the data set, whether the feature is really important or not. So likewise, so second thing is diagnostic analytics, so which will consider the descriptive analytics and build on top of it to understand why something happened. Like so it will give some sort of knowledge to exact information based on your descriptive analytics. Hospital data set, so that we have a patient id, patient name, patient age, right? Patient gender. So likewise, so here in descriptive analytics, so each and every instance will be verified, like is patient name necessary, or is patient age necessary, or is patient gender necessary. Likewise, analytics analysis will be done at your descriptive analytics. when we talk about, so if a particular person who age is greater than 60, so there may be some sort of reasons to get some sort of illness. So at that case, age instance is important, right? If he or she is an woman with age 60, then there may be chance of getting some sort of other illness what male can't get. So likewise, such sort of analytics will be done using diagnostic analysis. When we talk about this predictive analytics, entire world is depending upon this analytics itself. Prediction. So this prediction which talks about so there may be a chance of getting something in future, so based on previous experience, so based on traditional information, so that we it will take the help of this diagnostic and descriptive analytics, and using machine learning techniques we will do this predictive analysis. Then we go for prescriptive analytics. This prescriptive analytics talks the prediction from the predictive analysis and takes it a step further by exploring how these predictions will be happen, right? So what algorithm, so why we use this algorithm to do this prediction. See why this k, for example, if we talk about this classification algorithm, why k nearest neighbor is efficient when we compared with random forest, right? Sorry, decision tree. First, we compare this traditional algorithms, like why decision tree is very not that much accurate when we compared with k nearest neighbor. See what happened, what this ensembling algorithms will do. So it's that sort of prescriptive analytics that we can do with this type of analytics. Next we go for, so what are all the tools? So we saw like big data tools and technologies. So now we go for data analytics tools. So we have both open source tools and commercial products available for this data analytics. So we are very much familiar with Microsoft Excel. So what we are 100% using in our day to day lives, so that is completely depends upon some sort of Microsoft related stuff. We can't say it as an open source, right? But for some they'll give free. So if you purchase laptop means they'll give free windows, right? So likewise, but anyhow it is also commercial. So when we talk about open source tools, so this Apache Spark is an open source tool, right? And for single node Hadoop HDFS, single node HDFS is also open source. So likewise we also have both open source tools as well as commercial tools. While considering your cloud, when we talk about this cloud to store this large amount of data and doing analysis or analytics on cloud, right? Storing data, it's a part, and doing analytics on cloud itself a part. All right. So when we consider cloud provider, Azure is known as a best platform for data analytics needs, and it provides a complete tool set to cater any needs with Azure Synapse Analytical Suite. So it have everything. See on what basis you need to do analytics, right? So Apache Spark based data bricks and HD insights, right? Machine learning, everything. So here we shouldn't consider like as a cloud. So it is general cloud, a storage platform. So of course, so cloud is an on-demand service provider. Am I right? So of course it is an on-demand service provider, but Azure is an open source service provider where it will store the data. So if we want to process the data, surely we need to take uh, help of machine learning to do analysis. Next we go for, I'm audible.
Yes, madam, you are audible, madam. Please.
Next we go for AWS and GCP also provides some sort of open source tools like Amazon QuickSight, right? Amazon Kinesis.
Madam, your slides are not movable, madam. Please. One of the participants told, madam. Please check once.
So now it has changed, sir.
No, no, madam. No.
No.
Uh-huh. Still in the characteristics of big data.
Okay.
No issue. Please go ahead. Now, okay, madam, please. Madam.
Okay, okay, sir. Is it visible now?
Yes, madam, visible.
So now the screen is changing, sir.
Yes,
Yes,
madam.
madam. Changing, madam. Screen is also changing.
You
Okay.
applied on which table? Which table? Yeah.
Right. So these are different
So
type of analytics
right.
what we learned now. So that is descriptive, diagnostic,
Say this
predictive,
also.
and prescriptive analytics. And we already discussed about that data analytics tools and techniques. So we have different types of data analytics tools, so like open source tools and commercial tools. So we all know like Microsoft Excel is also a paid version which it won't get free, right? So we are using some sort of secondary version, that's a part, right? So anyhow, that is also Microsoft Office is also a commercial product. And we talk about open source product, Apache Spark is the only one which is completely open source. And of course we know about this cloud provider is also on demand service provider. But anyhow, this Microsoft Azure is a type of open source, right? So it is the best platform for doing analytics. And second thing is, when we talk about this AWS and GCP, these two are, right? So service providers, 100% these two are service providers. But so for some period of time, this AWS and GCP will work like open source, and after a particular time limit or something it will convert it into on demand version, right? So that is the thing. So AWS and GCP will work for open source platform for some amount of time or for some amount of memory usage, right? After that it will insist us to pay. So additionally, there are specialized business intelligence tools providers are there, so which is most powerful analytics and fundamental analytics is there. So where when we discuss about this Power BI, so we can able to do some sort of processing of business intelligence, and which we can driven different type of programming languages with this business intelligence, like Python, R, Tableau, right? So likewise, so completely this will create some sort of custom analytics scripts and visualization for the targeted and advanced analytics who needs actually. Finally, machine learning algorithms like TensorFlow, scikit-learn can be considered as a part of this data analytics toolbox. So these are the very useful analytic techniques. So I said for doing analytics, surely we need to take the help of programming languages, but the very handy programming language is Python, because there we are having there Python is very rich in libraries. See, among that, the scikit-learn is it's a one type of a library. TensorFlow is another type of library. See, uh, practices in data analytics. So if as we are all academicians, right? So we are all we are on in academia. So what we need to know is, if we need to work on data analytics or data related stuff, so better we need to know about what is meant by business intelligence. So how this business intelligence differs from data science, and what will be the current architecture of our business intel or current analytical architecture of our data analytics, and what are all the drivers of big data, so which makes us to drive the information. So likewise, so when we talk about this business drivers and advanced analytics, so optimized business operations, right? And identifying business risk, predict new business opportunities, comply with laws on regularity of requirements, all these things which leads us to business drivers. That is, which makes us to, so if some business, some, or if we need to start some sort of startup, so that startup should be in such a way, like, so where the same product should not be available in that particular region, right? So that which we call it as business drivings. right? So if we are selling milk in the place where milk is not available, so that is a type of business trick, or that we call it as a prediction of using that milk business in a particular area. So likewise, so optimizing business operations like sales, pricing, profitability, efficiency, likewise. So when we talk about this identifying business risk, so when we go for this credit card fraud detection, and how we can make that fake calls, right? So all those things which we call it as identifying the business risk prior entering into the business. Next we go for predictive new business opportunities. Just now I said like upsell, cross sell, best new customer perspective. Upsell is nothing but, so on which area we need to sell which type of product, so on which season we need to sell which type of product, or which we need to keep a business to help customers. So likewise, and compile with law or regularity requirement. So anti money laundering, fair lending. So there are different type of Sarbanes Oxley. So all these things are some sort of laws for business intelligence. So where we need to do anti money laundering, so where the money should not waste or the resources should not waste. See, all this stuff are which talks about the business intelligence. So when we talk about this business intelligence, so surely we need to talk about the data science, because we know about big data. We already know about, just now we learned about data analytics. Now we need to know about what is meant by data science. So here everything depends on data: big data, data analytics, and data science. So there will be some sort of, right, contemporary link between big data, data analytics, and data science. So data science is a multidisciplinary approach, so that extract information from data by combining our scientific methods, statistics, programming, advanced analytics, machine learning, artificial intelligence, deep learning, neural networks, right? So likewise, so in our data analytics, the primary focus is to gain meaningful insights from the underlying data. Am I right or not? Just now we saw like, so data analytics will be primarily focusing on the big data, right? So but now the data science, which completely an statutory body which extract information from the analytics part for creating new analytic algorithms, for analyzing complex data, and different type of tools for processing the data, and filtering your data, and building some new powerful and useful visualizations, right? So these are and multidisciplinary stuff like gathering information from schools, gathering information from colleges, gathering information from corporate office, so doing some sort of refinement. So like saying like, so the student who got 80% in his 10th, they may get an opportunity, or they'll get some sort of 75% in its graduation, so they will get this amount of salary. So likewise, a type of analytics, gathering data from school, college, from software industry, and doing some sort of processing, right? So here it doesn't say about one particular stuff, it talks about multidisciplinary approaches for extracting the information. So here we can able to create new type of analytics, or new type of analysis for processing. So now discuss about the data science tools and technologies. So we have seen big data tools, and we have seen data analytics tools, and we talk about now data science tools. So data science includes programming languages like R, Python, Julia, so which can able to create new algorithms. So of course we are very much familiar with machine learning models, AI process for big data tools like Apache Spark, Hadoop, and all. So data pre-processing or processing and purifications, such as WinPure tool. So there's a very new tool available for data science, WinPure tool, where we can able to filter the data. See how we filter the data based on the bias, based on the variance. Am I right? Right. So this is the stuff what we learned at the first stage of machine learning. So for data pre-processing or for data purification, so we use variance and bias. In of course the same terminology will inherited in this WinPure tool. And we have data ladder, and we have data visualization tools such as Microsoft Power Platform, Google Data Studio, Tableau to visualization. See, and in Python we use Matplotlib and Plotly. So these are different type of data science tools for doing analytics. So a data science which covers everything related to data. It covers completely whatever stuff that we need for analytics, that will be covered, right? So any tool or technology that is used in big data and data analytics can somehow be utilized in this data science process. So this data science, which is nothing but combination of your big data and data analytics. So this is our analytical architecture. So this is a very basic scratch analytical architecture. So what this shares is, so data source, from where we will get the data. From where we will get the data? From text, see, from Excel reporter, general reporter. So we will get different types of data. And what we will do? So that will be given to what? That will be given to enterprise data warehouse, where it can able to store your data. And we have different type of analysts, right? So this departmental warehouse data that is given to the data analyst. So and after that, this data analyst gives data to the enterprise thing, and this will be understood. Second one, enterprise data warehouse, that is collection of data is available at the place called data warehouse, from who will do some sort of analytics. Some persons, or they'll do analytics using different type of programming or machine learning likewise. See, from the EDW data is readed by different type of applications. And finally, data scientists get data from downstream analytical processing, and they will display the data in terms of dashboards, see here, reports, alerts and all. And finally that is viewed by your data science users. So this is the general analytical architecture. So there's a general flow of architecture. And when we talk about this business intelligence versus data science, see, data science which having some sort of predictive analytics and data mining, combination of, see here, predictive analytics and data mining. Predictive analytics means combination of descriptive analytics and diagnostic analytics, right? So why we need to use this, right? So the necessity of using this, both gives a type of predictive analytics, and of course we do some sort of mining, right? So that will be comes under your data mining. Combining this predictive analytics and data mining is nothing but data science. Here we have different type of techniques and data types, and we have some sort of common questions will also be there. So is it structured, unstructured, right? So how many sources we need to get the data? So whether it is large data, whether we need to apply predictive modeling techniques or any statistical techniques or optimization techniques, whatever. So all those things are different type of things. So what are the standards and what are all the reports that we process? So business intelligence is nothing but data science. So business intelligence is nothing but data science. Here we have different type of business intelligence. Dashboard alerts, queries. So all those stuffs are technical stuff that we required for business intelligence. So of course there are also some sort of questions will generate how many products that we need to sold. Everything will be available in business intelligence when we compared with our data science. So both are very very important for analytics part. So business or industry related analytics or business related analytics, right? So this data science and business intelligence both are required. See, so both are this horizontal line which says about past to future. So this vertical line says about exploratory analytical approach, right? Exploratory and analytical approach, where finally basics data analytics and data science, which helps individuals or the difference or every stuff,
Madam,
everything
one of the participants asked,
thank you.
please share the content, madam. Okay, no problem. I will share all the resource person content taken. Once again, I will share all the mails to you. Any other questions?
Any queries, please?
Okay, madam. Dear participants, any queries? Okay. Madam, Dr. K. Sridhar, madam, thank you, madam, for your valuable time and explaining about the data analytics and big data analytics, madam. Thank you. Once again, I will thanks the participant from various states contributed their part. You have turned up such a great number. Without their support, Day-1 program would not be successful. Thank you so much for your keen interest and participation in this FDP. Thank you, madam.
Thank you, sir. Thank you very much, Dilip sir.
Madam, thank you, madam, for your valuable speech in topic, madam. Thank you, madam.
Thank you, sir. Thank you very much.
Friends, any queries? Otherwise, we will close the session. Feedback link kindly send, sir. Okay, I will say. Any other queries?